Hello everyone, I am Alexander, still on capacitors and capacitance. At the end of this lesson, you should be able to derive an expression for the capacitance of capacitors connected in parallel. Yeah, for parallel connection, we have three capacitors. We take an example, three capacitors connected in parallel shown here. We have capacitor 1, C1, C2, C3 connected to a voltage source V, like a battery. Now, the features of this circuit is this, that the equivalent or combined capacitance given by this expression, which we want to show, C1, C2, and C3 are all at the same potential difference. The total charge Q is Q1, Q2, Q3. This can be explained further if we consider, here is capacitor 1, this is capacitor 1, and we have another capacitor here. They have this power connection where we have connected to a source of EMF, like a battery with a source. This is C1, capacitor 1, with capacitor C2, capacitor 2 with capacitance. When current flows to this point, the current will divide into the branch, the different, and here will be charged. Here will be charged. The capacitor will have a charge of Q1 stored here, and the current that goes here will have Q2 stored here, and likewise Q3 stored here. Then we have the total charge given as Q1 plus Q2 plus Q3. That will be the total charge there. Generally, we know that from previous lesson, the charge is the capacitance time multiplied with the voltage source here, the voltage. And then each of these charge store in the each of the capacitors, they have different charge store, but they share the same voltage because they are connected in parallel. When two or more components are connected in parallel, they share the same voltage. Because of this, Q1 can be expressed as C1V, the voltage, same voltage, the capacitance 1 of capacitance. Then Q2 is C2V. Q3 is C3V. If you label this as equation 1 and label this as equation 2, and this is equation 3. That's equation 3. And I'm going to substitute equation 2 and 3 into 1. That means substitute 2 and 3 into equation 1. Equation 1 can now be expressed as CV is equals to CV1, C1V plus C2V plus C3V. And then CV, V is common, and we factor out that that's C1 plus C2 plus C3. And C can get rid of the other V here, and this end up we have results. C is C1 plus C2 plus C3. That means when you connect capacitors in parallel, you have this combination. That means the effective capacitance given by the sum of the individual capacitance of each capacitor adding up to have the overall capacitance of the combination when connected in parallel. Here's an example. In this example here, we have two capacitors of capacitance 2 microfarad and 3 microfarad are connected in parallel. Yeah, in this example, we can say that C1 is 2 microfarad, and then C2 is 3 microfarad. Since they are all connected in parallel, the diagram will look like this. This is how the diagram will look like. This is C1, C2 connected to a source of EMF. So the effective capacitance in parallel is C1 plus C2 will give you 2 plus 3. You end up having 5 microfarad, 5 microfarad. So this is all we can say about when you connect capacitors in parallel. You add all the capacitance of each of the capacitor together. Follow this link, you'll find an assignment that have to do with capacitor and capacitance. Thank you for watching.